be talking about fractions. So the whole unit will involve fraction. How do we convert between fractions? How do we add, subtract, multiply, divide? How do we compare fractions? And how do we do word problems involving fractions? So the first thing we're going to talk about is how to convert between a mixed fraction and an improper fraction. So a mixed fraction would be something like this. It has a whole number with a fraction. It's mixed, whole numbers and fractions. An improper fraction would be something like this, where the top number, the numerator, is bigger than the bottom number, the denominator. So 22 is bigger than 5. So how do we convert between the two? Because you may see an answer that's in a mixed fraction, or you may see it as an improper fraction. And also sometimes we have to convert between mixed and improper so that they're easier to work with, whether we're multiplying, dividing, adding, and subtracting. So we're going to look at these 3 steps here. So what I would suggest, write these in your notes. You have them to refer back to later. So in this one, it says multiply the bottom number, so our denominator, by the whole number. So we're going to multiply this 2 times the 5. So 2 times 5 will give us 10. And then it says add the answer to the top number. So this 5 is going to be, or whatever we get from here is added to the 1. So 2 times 5 is 10, plus this 1 we have on top is 11. Keep the bottom number. So we keep the bottom number, and this answer right here becomes our new top number. So 11 over 2 is the improper fraction that means the same as 5 and 1/2. So to go from improper to mixed, we're going the opposite direction. So instead of multiplying, we're going to divide the top number by the bottom number. So divide the top number by the bottom number. So 22 divided by 5. So 5 goes into 22 4 times. And 4 times 5 is 20, and we have a remainder of 2. So that 4 becomes our whole number, and the remainder becomes the top number. So that remainder becomes our numerator. So then we have 2 over, we keep that bottom number. So if you notice in both of these, we keep the denominator the same. They're not going to change. So let's look at a couple more examples. And like I said, make sure you have this in the notes. Pause the video so you get a chance to write them down. So our first example, we're going to work on mixed to improper. So we're improper to mixed, pardon me, 54 over 7. So we think back to those steps that we had in the examples. Our first step is to divide the top number by the bottom number. So the top number goes in our house, the bottom number is on the outside. When we divide those, 7 goes into 54 7 times. Again, you can use your calculator on these, that's fine. Now we're getting into the more complicated stuff. We can practice using our calculators. It's not likely that something like this will be in those first 10 questions. And if it is, it's going to be very easy math, something you can do in your head. So 7 times 7 is 49. We're going to subtract that. We're going to have a remainder of 5. So this number that we get in our answer here becomes our whole number. Our remainder becomes our numerator, and our 7 denominator stays the same. So we get 7 and 5 sevenths. So let's go ahead. Let's do one more together that are improper to mixed fractions, and then I'll give you a couple to do on your own. So let's look at 41 over 10. First step, we're going to divide that numerator by the denominator. So 41 divided by 10. 10 goes into 41 4 times, and 10 times 4 is 40, which will give us 1. So a remainder of 1. So this 4 becomes our whole number. The remainder becomes the numerator, and we keep that 10 as the denominator. 4 and 1/10. Let's look at this example I gave you. So we have 61 over 9. So our first step is to divide the numerator by the denominator. So 9 goes into 61 6 times, which will give us an answer of 54. So when we subtract those two, we should get 7. So a remainder of 7. That 6 becomes our whole number. 7 becomes the numerator. We keep the same denominator. So you should have gotten 6 and 7/9. So try this other example. Example, we have 70 over 48. Same things we've been doing. Take that numerator, divide by the denominator, which 48 goes into 70 only one time, which would give us a remainder of 22. So 1 is our whole number, then 22, our remainder, is our numerator. We keep the same denominator. Now, what's interesting about this one is something we haven't talked about before, is reducing fractions. So if you have these large numbers, we want to reduce them to the smallest numbers possible. Now, what that means is we're looking for a number that the top and bottom can both be divided by. So looking at 22 and 48, those can be further reduced because there are some numbers that can go into both of them. For example, in this one, 2 can go into both numbers. So 22 divided by 2 and 48 divided by 2, because we are reducing it evenly. Basically, what fractions are, is there a ratio between two numbers. So 1/2 is the same as 2/4, which is the same as 4/8. Those are all proportional to each other. They're all the same. They're just bigger numbers to represent the same amount that is taken out. The same fraction, just in different numbers. So what we'd have here, we can divide both of these by 2, which would give us 11 over 24. Now looking at those numbers, nothing can go into both of those numbers evenly. So we have 1 and 11/24. So when you think about the test, you might get this answer right here. So this 1 and 22 over 48, but not see it in the answers. So if you don't see it in the answers, look and see if you can reduce it further, because 1 and 11/24 might be the answer on the exam. All right, so let's look at converting some mixed fractions to improper fractions. So this one right here, we have 6 and 4/5. So what we're going to do, multiply that denominator by the whole number, add it to the numerator. So we have 6 times 5, which will give us 30. Add it to the numerator, plus 4, gives us 34. This becomes our new numerator, and we keep the same denominator. So we should get 34 over 5. So let's look at 2 more examples, and then I'll give you some examples. So we have 7 and 2/5. So multiply, add. So we have 7 times 5 is 35. Add it to that numerator, 37. So 37 is our new numerator. 5 remains our denominator. All right, last one together. We have 3 and 8 over 20. So multiply, add. So 20 times 3 will give us 60. Plus 8, 68. So 68 is our new numerator, and 20 is our new denominator. Looking at these two numbers, I already know right off the bat that they can both be divided by 2. It could be that there's something bigger that those two can be divided by, but I'm going to start out with 2 because I know for sure 2 goes into each of them. So 2 goes into 68 34 times and into 20 10 times. Looking at those numbers too, they're both even, so I know that they can both be divided by 2 again. 34 divided by 2 is 7. 10 divided by 2 is 5. Now looking at that, there's nothing else that can be divided into that number. But again, we're making it so that we have easier numbers to work with than these bigger numbers. You might get this answer, but it's not going to be the answer on the test. They're looking for the reduced number. All right, so look at this example and try it out. We're going to do the same thing we did earlier. So multiply and add. So 26 times 4. 26 times 4 should give us 64. And then we add it to our numerator. So plus 20 gives us 84. So we have 84 is our new numerator. Keep the same denominator. Again, looking at these, they both can be divided by 2. So I'm going to divide by 2, which will give me 42 over 13, which that can't be divided anymore. So that becomes my new answer. Try this last example on your own. Before. Multiply and add. So 48 times 2 will give us 96 plus our numerator 132. So 132 becomes my numerator. Keep the same denominator. Looking at both of these, I know that 2 goes into both of them. So let's see what divided by 2. So that'll give me 66. Let's start 132 divided by 2. 6 can go into that. So yeah, 66. And again, you can use your calculator. And this bottom number becomes 24. Looking at those, I know that 2 can go in them again. So that's what I'm going to do. So 2 goes into that 33 times and into that 12. Even from there, we can divide it by 3. 3 goes into that top one 12 times, and the bottom one 4. So 11 over 4. When I'm not sure what to reduce, I mean, if you see me kind of look at those and go, okay, does 4 go into 1? And you could try it in your calculator. Does 4 go into 132? Does 4 go into 48? What I like to do, though, start with 2. The 2s and 3s. Can 2 go into it? Can 3 go into it? And that usually gets me to the right answer. Again, start using those calculators. Get familiar with how to use them. Get familiar with how to get them to help you out with some of these problems. All right, and that's the end of the first lesson.